My name is Trey Morrow. I'm a sales engineer with Algorithmia. I'm joined by Megan Corbett, our marketing manager, Zhilei. He's one of my teammates, is a sales engineer as well, and James Sutton, one of our ML solutions architects. I'm going to go through a walkthrough of our platform, give you some background on it, and then go through a demo. And then I will then hand it over to James to do some additional demonstration with GitHub Actions and whatnot. So let's go ahead and get started. What is Algorithmia? Algorithmia is an ML learning operations and management platform. We ease deployment and management of models at scale. For most projects, using the right tools makes the difference between success and failure. This is especially true with machine learning. We have met with hundreds of machine learning teams and consistently hear frustration that their efforts are being held back by immature infrastructure. This includes things like algorithms being stuck in the lab, never making past a proof of concept, disconnected teams, be it geographically or through different organizations or sub-organizations, or different technologies, or different languages, technology mismatches, where you're trying to deploy different types of training models with different technology background or platforms. Stakeholder buy-in. A lot of stakeholders don't realize the ROI that they've invested in, and then there's hidden technical debt of producing a production-ready model to serve. As a result, this ends up being an inefficient machine learning lifecycle, and also as a result, 85% of machine learning projects fail to scale past the proof of concept. Furthermore, it can take up to 18 months for models that do make it into production to get there. Algorithmia addresses this in these 5 challenges by addressing ML development, deployment, and operations. We've created a single platform to close the gap between tooling and operational skill sets. This includes ML development backed by Git repository. We leverage the current frameworks with 7 different languages, including Python, Java, JavaScript, R, Ruby, Rust, and Scala. Although we ship an embedded Git repository, Algorithmia also works with your current GitHub, GitLab, or Bitbucket deployments. In terms of deployment, Algorithmia is available via an on-prem or cloud provider of your choice. We build scalable, connected algorithm API pipelines callable via 14 different languages, and each algorithm can be called individually with its own API from different applications. For DevOps and infrastructure, we ensure performance, availability, security, and compliance of services. And additionally, we create and enforce architecture and service standards, enabling proper ML governance for the entire lifecycle. Let me take a sip of water here real quick. I'm going to dig down into some of the data science workflows where our customers realize the most value. As far as development, we support whichever frameworks and languages you're currently using, be it varying languages, frameworks, and environments. We're not opinionated on how you're serializing your models or what frameworks we're using. 2 things go into Algorithmia: a save to train model and a serve or scoring function. Where we converge on the right is a powerful platform to build and achieve, ML initiatives. We have a powerful set of capabilities that empower you to achieve more faster. This includes proper coordination between people and organizations, established processes between multiple systems, support for the latest state-of-the-art technologies. We provide access control, versioning, audit capabilities, model performance monitoring, and enabling compliance with governance and security requirements. So think of this as divergence on the left and convergence on the right. So we're leveraging your current technologies and productionalizing them in one environment. So where do we fit in? We operate between your data systems, platforms, frameworks, and your consuming applications. So we deploy and operate and secure your models, catalog them, version them, set up pipelining, model governance, handle the different languages and communication between the two. Dependencies for your models when they're deployed. We handle compute, orchestration, hardware, and then also model monitoring. So when you're consuming apps, reach out to your algorithms via an API, and where the output is served. Excuse me. So I'm going to go into a demo here, and let's go out of here, and I'm going to pull up our landing page. So this is Algorithmia Enterprise. So this is, once you log in, this is going to be the landing page for your environment. Like I said before, we catalog all of your models, and you can organize them into different subjects or different categories. And this is customizable to your environment. You can go into the admin console and change these however you want. We connect data sources via our hosted data source, and Amazon S3 can connect to your current S3, your current Azure Blob storage or Google Cloud storage using your, your access controls, so that we leverage what you've already got, but we also provide access controls at the API level. We have hosted data collections, like I said before, and these are basically where we're landing either our trained models or our images or input that each of these models are consuming. And then we can also put output here for another model to pick up. For additional data connections, we can leverage your code inside your Python, Java, etc. We have walkthroughs on how to do that from different data sources. For example, Snowflake. This is some sample code on integrating a Snowflake connection. Additionally, we've got a secret store feature coming out, so you don't have to put your username, password, and all your account info inside of the code. You can leverage a secure secret store. So that's coming in a few weeks. I'm going to go back to our landing page, and these are the algorithms that I've been working on. This is a new cluster, so this will hold the top 6, but these are, if I had more on there, it would show up. But one of the things that I wanted to kind of illustrate is organizations. So say you're a large financial institution, you've got a bank, insurance company, a call center in one environment, and you want to segregate your algorithms, your data, your access, your auditing, everything. You can break that down into here. This is basically a collection of algorithms, people, and data that all reside in the same place. So this allows you to publish your algorithms to a specific organization or your entire enterprise. Next, I want to go into API keys. And so API keys are a big part of our security and governance. Each API key can be scoped to a specific use case or algorithm. So if I want to create a API key for a use case, I'd go in here and say, this is my new key. And then whether or not it can access other algorithms, or if I just want to have data access, or if I want data access only or as well, I can do read write or read only access. So I'm going to create an API key, and this is actually this is the new one here. So you choose to hide that or copy it. We handle event listeners. This one is configured to set up or to work with Amazon SQS, but we work with Google and Azure as well, in addition to Kafka event listeners. Excuse me. So next, I want to go into one of the Algorithmia SE organization, and I'm going to bring up a sentiment analysis pipeline. This is basically an algorithm that is part of a series of algorithms with different technologies that produces a sentiment analysis on a excuse me, on a press release. So I'm going to search by keyword. As I mentioned before, things are organized by, excuse me, by categories. And then when in each of your algorithms, you have keywords that you can search by. So I'm just going to do sentiment analysis. And it pops up. And then this is the landing page for each one of your algorithms. So anytime you create a new algorithm, it'll create a blank landing page, documentation and whatnot, and you'll go in and fill this in. So basically there's a brief description. These are the keywords that I mentioned, which language, how many API calls this has taken, average call duration, and then the permissions that I mentioned earlier. So this is private to this organization, has internet access, and we can do pipelining with this. Next up, we have some example input. So basically, each one of these algorithms requires an input, and this is just a text string that tells it where to find the different components that we're going to load here in a minute. And then I mentioned earlier that we can call these from 14 different languages. So basically, if you, this is a Python algorithm that we're calling directly, and we can call this from a command line with a curl statement, Java, JavaScript, C#, Python, R, PHP, all of these. So if you've got another application that wants to consume this, you basically say you've got a PHP app on a website that wants to consume this, and you just use this code right here. You paste that in your PHP app, and it'll call this using the API key and this specific version that we've put in here. So if you want to call it just the latest version, you can take off that part of the link, but we recommend you anchor it down to a specific version, and that way you ensure continuity when you're making changes. So a couple other things I want to go through is the documentation. So this is this starts with a template when you create a new algorithm. We filled in the summary and the overview. I'll get into this in a minute. And then we've listed the different algorithms that are upstream in this pipeline. So we basically, actually I'll open this here. So basically this algorithm takes a scanned document, put it through a text OCR, Java-based GPU served algorithm, feeds it to a language identifier using Python and scikit-learn. And then from that point on, we figure out if it's English, then we go straight to text vectorization using Java, or if it's in another language, we push it through Google Translator using Python and TensorFlow. Once we get that done, we then vectorize it and then do sentiment analysis using Python. So we've got a whole pipeline here of different languages, different technologies, and different platforms and different frameworks, all in one pipeline. So, and these are all connected and calling each other via API. So we've got some additional documentation down here, and basically what the input is and describing. This helps with governance and basically documentation of your algorithms. And we've got some sample queries in here, and then sample output. So this is what the output will look like. Excuse me. As I said before, we handle event listeners. And I'm going to go into settings here. And so, like I said before, we ship an embedded Git repository, but we work also with GitLab, GitHub, and Bitbucket. So basically, if you wanted to use this, if you wanted to modify this algorithm, you can clone this using just git clone, bring it down, make your changes, commit them, and push it back. And what it'll do is it'll create what we call a build. And that is basically your servable model image that you can call directly. Each time that there's a build done, it's listed here. So we keep those in perpetuity. So all of the different versions that you've modified and then built, you have these here. And then once you've tested it, you can either publish it here or you can do it from the source code. We also handle versioning. When you publish a algorithm, you have the option of versioning, which I'll tell you here show you here in a minute. But this is where we keep the different versions and release notes on this page. So this was actually developed using the embedded IDE. Like I said, you can use things like PyCharm, Anaconda. We actually have Conda support coming out here shortly. But you can use the IDE of your choice and then interact just like you would with a Git repository. So this model actually pulls in the OCR file using this algorithm right here, determines language, and then if it's not English, then excuse me, we pass it off to Google Translate, which is actually hosted by our platform, and then we tokenize the text itself, and then we build a sentiment analysis on that. And that's what's outputted from there is that's a API key. What's outputted from there is the excuse me, the sentiment and the excuse me, the sentiment, and then the token. Anyway, so say if I wanted to make a change in here, I can switch over to an externally hosted, or if I wanted to change the version or just take out the version on this, I can run this and I can build it. And so that's basically zipping up everything, packaging it and getting it ready to serve. And so what happens is when this is done building, it's going to give me a new key at the bottom saying this is the latest one that's available. While that's going on, I'm going to copy a sample input. Oh, there it is. So we have this new version, or this new build, so to speak, ready for testing. So I'm going to go back into here and grab that text input. I'm just going to copy it from here. And then I'm going back into the source code in the console at the bottom. I'm just going to paste this in here. And so this is a brand new build. We made this build as I'm sitting here talking to you. And so it's spinning it up. And yeah, so we didn't like that version. So I'm just going to revert it back and rebuild it. So I generated an error. I'm going to revert back. I've tested it against what version that is. And it is rebuilding. So, and I'm doing this all in real time. So basically, okay. So I'm going to go ahead and publish this and release notes and continue. And then, so this is the sample input that we showed before. And so we'll run the algorithm itself. And so that came back out. So we've tested it. You can either test it in the previous screen or test it here. I just made a change to show you that we can update it and rebuild it as we're working here on the fly. So next, this is where security comes into play, and also versioning. So we can publish this publicly, and this public is actually just to your entire enterprise, or you can publish it to whoever the owners are. When you create a new algorithm, you can assign it to yourself, or you can assign it to an organization. Then anybody in that organization is an owner and call this version. So we support revisions, minor and major changes. And then insights is something that I'm going to show you next, which enables us to collect metrics on each algorithm. And I'll get into that in a minute, but I'm going to publish this. And so now this is the live version of a brand new build of that algorithm. So I've gone in, I've changed something, found that I didn't like that change. I went back and I reverted back and then republished it. So this is back to where it was. It's versioned properly. So this is one that I just put in. And so that's the live version. Excuse me. So it's really that easy to build, modify, manage, and serve algorithms. Like I said before, you can call this from different applications, call it from other algorithms using the code that we provide. So I'm going to pivot back to some slides here, and I'm going to get into our new Insights product, our new Insights feature. And if I go into full screen, so Algorithmia Insights. This is a metrics pipeline which you can use to monitor and respond to model performance in production. Insights allows you to integrate with any monitoring tools such as Datadog, InfluxDB, New Relic, Kibana, and visualization tools like Grafana. This enables you to track things like data drift, concept drift, model variations, and then respond in real time. So Algorithmia Insights helps you identify and correct things like model drift, data changes, and negative feedback loops. It allows you to respond in real time to changes in model performance and mitigate model decay. It helps you identify models that need to be retrained, give you greater adherence to compliance with internal and external regulations, and reduces your risk of model failure. As for capabilities, we stream 90 different operational metrics such as model name, version, duration, plus session and request IDs. Additionally, we provide developers with the capability to specify their own metrics. We offer the flexibility to work with monitoring and analytics tools via Kafka metrics pipelines. With each algorithm, you have the control over which metrics are exported. And I'll show you how to do that here in a second. Then finally, we integrate easily with common monitoring and reporting platforms such as Datadog, InfluxDB, New Relic, Grafana, Kibana, and more. I mentioned those earlier, but we also recently announced a partnership with Arthur AI. Excuse me. So how does this work? Using Insights, you can specify custom metrics that you want to use to measure Python, Java, Scala, or R models. We input data, model attributes, or other output predictions. Each time your model is queried, Algorithmia streams these metrics to a Kafka pipeline. This in turn is integrated with a wide range of monitoring and observability platforms. From here, you can just perform things like real-time monitoring and alerting. And I'll show you a Datadog integration here in a second. But let me show you first how we achieve this, or how you instrument these things. So like I said before, we feed 90 different operational metrics, but we have the ability to instrument specific, specific metrics based on your algorithm. So if there's something in your algorithm that you want to track, you can instrument it and send it back through Kafka, then pick it up with a monitoring tool. Like I said, I'll be showing you this in Datadog here in a second, but this is a credit card approval algorithm that we've got running on one of our clusters here. And it takes some demographic information and then produces either a credit approval or a disapproval, or 1 is an approval or 0 is a disapproval, and then a risk score. And those are 2 of the metrics I'm actually going to show you in a Datadog dashboard. And so like the others, you can call these any other way. I'm actually going to feed some dummy data using the curl option here from my other workstation, but I have a script that runs a set of commands that feeds some data into there. Let's go into the source code. I showed you before when we clicked publish, there was a checkbox to enable insights. And so the other aspect is that you can instrument what you're feeding, what you're processing in your algorithm, and you can track basically anything inside of your algorithm. So with this, we're actually loading a serialized model. We got 2 different ones that we can switch back and forth between. We apply a set of inputs for, I think there's 29 different features, but the dashboard that I'm going to show you here in a minute shows you how many features. And then we produce the risk score and then an approval. And so that's the output. So what's different here, though, is these lines of code at the bottom. So we're calling a insights client and saying, okay, we want to feed risk score, and that's the basically data label, and then the approval, and then also the number of features from here. But we additionally want to track some of these features that we feel important. So we're adding owns home, has work phone, and you can put any of these other features in here. So when you run that, every time that this algorithm is going to call, it's going to feed these values into Kafka, and then you pick it up with Datadog. So what does that look like? I'm going to pivot over into Datadog while my other computer is getting synced here. And so this is the basic Datadog environment. We've created a dashboard with some monitoring that I'll illustrate here in a second. And my other computer, there it is. So there's no data flowing into this right now. I was feeding some in here earlier. I'm going to feed some live data in here on the fly. So I'm just going to do a slew of credit approvals, which is not a real case scenario, but you'll see the telemetry come in as it's being parsed through Kafka. And I may need to refresh here in a second. There it is. So we've got the telemetry, the average number of credit card applications, and then average approval rate. So we've got an average over this time period. So we're still at or near zero. As this picks up, as data is being fed through here consistently, you'll see the average approval rating change, and then risk score. And like I mentioned before, I fed the number of features back in through here. And so we're showing how many features are involved with that algorithm. When these, sorry, I mentioned the operational metrics here, and this is things like model duration. So we've got a histogram here and then an average model duration. So what do you do with this? If you use Datadog before, and this also works with InfluxDB and whatnot, we have some monitors set up. And so this monitor is triggered or set up to trigger when these metrics fall outside of specific ranges. So this is one that was triggered, and this is in the last minute. Average risk score is greater than 0.5. So if we had a super high risk score, we wouldn't want to be approving credit applications. And so we want to trigger an alert to make sure that our model's performing properly. And this is a illustration of, say, data drift. So as a result, we open a message in a a Slack channel where like a support team can monitor, take action, create an incident in your ticketing system and whatnot. Additionally, we can trigger, we have webhooks that trigger workflows. So if you want to automatically retrain based on your model's performance, you can do that here. So this is how we provide insights. There's how we provide visibility into your model performance inside of each of your algorithms. And like I said before, we feed a bunch of operational metrics, but we also give you the ability to track whatever you want and whatever is important to you inside of your algorithm. And with that, I think I will turn it over to James. You ready, James?
I am. I can share my screen. Let's see if I can get it to work. Does that work? Can you guys see this?
Yep.
Excellent. Perfect. Well, thanks so much, Trey. That was fantastic. Actually, you mentioned a couple things that I can talk about a little bit less. That's great. So this right here is a demo algorithm. So it is a hello world algorithm. It's a bit simpler than the typical machine learning workflow. That's perfect for what we're trying to demonstrate here. One of the things that Trey mentioned around algorithm versions is really important. Algorithms on Algorithmia are immutable. So once they're created, they're always going to exist or be capable of being interacted with by any of your downstream applications. So for example, we have not only just an algorithm that has multiple different builds, but this algorithm up here actually has a version 0.2.0 that has been released. What's nice about that is if we have some kind of system, if we have some kind of mechanism to ensure that this algorithm conformed to some specific standards, for like in a kind of in a traditional software space, then that would allow us to ensure that when this gets put into production, this is going to continue to function day in, day out the same way that you're expecting it to. To do that, we use something actually, so Trey mentioned that we actually do support GitHub and GitLab. We actually work with them to be able to enable algorithms to actually be supported directly on GitHub. So for example, unlike when Trey clicks source code, it's going to take us to web editor. When I click this, it'll actually take me to a GitHub repository. So this GitHub repository, if you're familiar, it's probably going to look relatively similar. You can see that we have a GitHub action workflow. We have a test cases file. But one thing that I want to take a quick look at first, just kind of with the assumption that I'm an algorithm developer, I've been working on this. I want to get this right. I want to be able to solve this issue. I'm going to click this red checkbox, red square. I'm going to click details, and I'm going to go here and take a look to see what's going on here. So we built a CI/CD GitHub action that allows us to make our machine learning workflows and potentially traditional algorithm development workflows that are being hosted on Algorithmia conform to some specific standard when you're actually planning to deploy things. So in this case here, we can see that this had two different test cases. One of them was called accepts an integer. The expected output was hello 1, and the real output was hello number. And I think as an algorithm developer, I know exactly what went wrong. I'm going to go and change my source code and recompile that. And after that recompile it, I'm going to talk a little bit more about some additional kind of components of this. So immediately when I clicked that recompile button, as Trey mentioned, when Algorithmia is connected to a GitHub or a Git management service, that automatically is going to trigger a new build. So if I refresh my page, you can see here that we've automatically triggered this new build, and it was completed in 19 seconds. If we wanted to, we can actually scroll down and actually interact with it directly. We can also see the build logs, which can be very useful if there is some kind of exception that occurs during compilation. But the interesting parts here I wanted to highlight are actually in the actual GitHub action tool. So we actually have on GitHub a GitHub action that can be incorporated into your own GitHub workflow that can take a number of different specifications if you're familiar with GitHub actions. So for example, your API key, API address, and version schema. And what we'll do is it'll wait until your algorithm is actually finished building, and then it will run a number of tests against your algorithm. If all of those tests pass, then it will actually publish and promote a new version based off of the definitions that you're looking to build out. Now, those tests are going to most likely be a bit different than the tests that you might normally see in traditional software continuous integration workflows. Because machine learning in general it doesn't necessarily always return the exact same response. There is non-deterministic aspects to machine learning workflows. Sometimes there's state to be managed as well. And the numbers and the things that the variables, like for example, accuracy, are numbers that will change potentially on different model deliveries. And ensuring that, for example, the output matches a specific input or matches an expected output can be really difficult to manage and maintain when you're building operational machine learning workflows. So in that case, in that world, we've created a number of different schemas to be able to conform to them, or to enable a conformance to a specific standard. For example, here, this is a bit of a more robust example of what one of those might look like. This actually performs a benchmark inside of your algorithm, and then it returns an output, which is your actual overall accuracy across all of your different images that you just tested with. As you can see here, we actually have a type of a case that actually is greater than or equal to. So if the result of this is greater than 0.7, then that's a check mark. If it's not, then that's going to be an X. So in the case of our demo that we were just taking a look at, if we take a look at our test cases file, again, super simple, just hello world, but there's a bit of nuance, which is nice to look about here. So these are both exact match types. One of them is hello world, which is just you pass in Algorithmia, you expect hello Algorithmia as an output. The second one is a bit different, which is because Algorithmia actually allows you to have a very flexible API and allows you to have accept multiple different types of inputs. So you can have a very robust kind of API interface that allows you to, that would allow you to be able to essentially create one algorithm that might have 10 or 50 different interfaces to perform different actions based off of what you're looking to do. In this case, when I pass in number one, I wanted to convert it to a string and return it as an output. If I go back to my action, we might, well, actually, nice thing, it already completed, which is great. So the new one that my fix is already in there. You can see what it actually did is it returned hello number. So I can see that and I can immediately go and get involved in actually solving the issue. Now that did trigger a build. So both of those triggered a build. So this one right here triggered a build right here. But it didn't actually get promoted. So it didn't actually publish a new version, which is what we wanted to do. If something failed, that's something that we don't want that to necessarily get into production, and having and incorporating continuous deployment and integration tests in conjunction with your machine learning workflows is something that we consider very, very important for a growing maturity of machine learning operations and machine learning within your organization. Now, for example, if I go and take a look at my source code real quick, you can see I have this. If you're familiar with Python, isInstance is a way to be able to tell the type of something, and we obviously were doing something that was causing us issues, so we commented that out, and as you can see, our workflow was successful. So if we actually go and take a look at the Algorithmia CI tests, we can see not only were all the tests complete, but we actually promoted a new version. So if I go back to my algorithm, which is over here, and I refresh the page, you can see, hey, we got a new version. So it's automatically published. So one of the really nice things that we can actually take advantage of in Algorithmia is, for example, if I take this URL right here, and I just take a look at it and just kind of inspect it. One of the things that you can do when you're calling algorithms is you can actually use wildcards. So if you want to be able to ensure that your algorithm, that you're getting the latest, for example, bug fix or hot fix version of a specific minor version from a semantic versioning perspective, version of your algorithm, you can 100% do that. And if you, and for instance, what might make sense is if you want to be able to control this, so whenever you make a normal release or make a normal kind of update without changing your test cases, you could actually trigger a revision or a hotfix update to your algorithm. And if you wanted to, if you adjusted your test cases file, then that might trigger a minor or a major version change. Those are things that you can build into your automation story inside of GitHub, inside of GitLab, inside of Bitbucket. And that's something that you can directly take into Algorithmia. So you don't necessarily need to build the tooling and the logic to be able to do those things. Thankfully, these platforms enable you to do this out of the gate. One of the nice things too that GitHub support provides us access to is the ability to, for instance, be able to make a protected branch. So for example, that main branch is could be protected. And that's the only branch that we're actually using for triggering GitHub actions. If we take a look at our workflow file, you can see right here that we're only making, we're only triggering operations on changes to the main branch, which means that if you want to be able to add additional layers of security in regards to how your algorithms actually get executed, you could, for instance, have this algorithm be used for production. So over here, this could be, let me just click this, if I can get the zoom overlay out of the way. This could be, for instance, your production algorithm that might actually be used by production. And then you could have a QA algorithm that could actually be being used by a quality assurance team. And both of those could actually link to the exact same GitHub repo. They just might be using different branches, for instance. So there's a lot of things that can be built on top. And one of the things that's great about Algorithmia is we're very flexible. Everything's API driven. So it's very easy to build these tools to wrap around and enhance the value that you're getting with Algorithmia and enhance the governance and security that you need to conform to in your organization to be able to feel safe in deploying production machine learning workflows. And I'll turn it back to you, Trey.
I think we're going to turn it over to Megan for questions and Q&A.
Yes, perfect. Definitely. Thank you so much, Trey and James, for your awesome demos and presentations. And thank you everybody for joining us today as well. We covered a lot of information and a lot of, really in-depth details, but we're happy to open up the next 10 or 15 minutes for some open Q&A. Feel free to use the chat box to ask any questions that you may have about Algorithmia's platform or its capabilities, or feel free to take yourself off of mute, and we are happy just to keep this more conversational. So to start things off, I wanted to ask you all, when it comes to working with Algorithmia's platform, if I were an individual data scientist, is there something or some product that I can use on my own? Specifically, is there a free offering, or is there something that I can use to hunt around with the platform?
Yeah, I think I can take that one. So Algorithmia has a free version. We call it Marketplace. That's basically where we started our business, several years ago. So today, over 130,000 data scientists are using this platform. And there you can find, I think, around 15,000 pre-built machine learning models. So you can learn from each other and build your models on top of other data scientists' work. So that's Marketplace is for free. Feel free to go to algorithmia.com. You can sign up and you can play around with it. And there's also a very well-written documentation, including tutorials, step-by-step. And also there is also videos available on YouTube channel, so where you can learn and follow the instructions.
Awesome. Thank you so much, Zhilei. Another question that we can keep this conversation going is, Algorithmia just released a new version or some new updates. Can you speak to some of the new features that came out with that?
I don't know how much we can disclose here. So definitely there are a lot of exciting features, coming up in terms of security, additional governance features, and also additional enablements, in terms of source code control management. So, stay tuned, and you can, go to algorithmia.com, follow our blogs, and we will definitely make announcement there. So there you can also find a lot of interesting articles. I think, James, you have also contributed a lot, basically showing people how you can use the advanced features of the platform to, facilitate reuse, to automate your workflows, and also how can you implement advanced governance across all steps of your machine learning workflows.
Some of the things that we have just launched are things like GitLab and Bitbucket integration. Recent releases include things like the insights that I showed you. And we have a secret store coming up in a future release where you can basically you can instrument your data connections without putting your logon information inside your code. So that can help, especially in like bank compliance, things like that. But so that goes into our advanced security and governance, and yeah.
Awesome. Thank you so much to both of you. I do want to open up the floor to the audience as well. Again, feel free to use the chat, or we can just take a moment for anybody who wants to hop off of mute to ask their question. Not to interrupt, but we did receive a question through the chat. Can Algorithmia as a platform be installed on-premise?
Yes, we do offer it as an on-prem in VMware installation, and we can be deployed in any of the cloud providers. But so yes, we can deploy on your inside of your environment.
Awesome, thank you. So would you be willing to talk more about the training materials and online resources to learn more about the Algorithmia platform?
Hey, James, can you take that one?
Sure. So yeah, so definitely I recommend taking a look at the Dev Center. So that's definitely, so I think Trey may have showed that early on in one of his demos. But the Dev Center, and I'll just share my screen once I get it a little bit up, is an amazing resource. It's something that we're constantly updating and keeping up to date. It can provide a whole bunch of information on how to actually use the product. Let me just actually share my screen again. And yeah, as you can see here, this is a great resource. There's tons of information here. All of it actually is, if you actually go to any of these pages in particular, they're actually all listed in GitHub too. All of the actual content around, for example, clients and the data API, all of those other different sources, you can find pretty extensive kind of walkthroughs from both a UI perspective and from more advanced features inside of the client's documentation. However, if you also want to go to, for example, if you're using Python and you prefer to read from the actual kind of engineering docs, we also actually provide documentation inside of all of our GitHub repositories for public-facing features that actually allow you to see how to integrate and how to interact with all of our different tools for algorithm development.
Great, that's wonderful. Thank you, James.
No problem.
So one last question I know I have, and this is a question that was similar to an event that we were working with the team last week, was the subject about governance and how that is becoming increasingly important for our customers as well as just organizations trying to, leverage ML and AI. So can you talk about how Algorithmia is managing that and incorporating that into our platform and workflow?
Yeah, so I can speak to a little bit of that. So governance is very, very important for most organizations. Regardless of whatever you're working on, you want to be able to control and understand and monitor different workflows and how they actually interact in the public space. It's a little tricky from a machine learning perspective to be able to make a one-size-fits-all tool to be able to manage and administer access, especially with all the variations between different enterprise systems, which is why we built the infrastructure to be able to link to existing systems and services, like, for example, Datadog or Splunk, or other data repository or analytics tools to allow you to integrate your Algorithmia or machine learning based governance operations in with your existing infrastructure, your existing logic. We don't want you to necessarily have to build something separate. Another big thing that's really important too is around reliability and maintainability. And that really speaks to, for example, our GitHub and GitLab integrations and how powerful those links can be by being able to take advantage of things like permissions and security and compliance systems that can be built in to those Git repository management tools all automatically. You might hear about GitOps on a regular basis, and that's something that is definitely something that we take a look at very, very closely in terms of machine learning operations, because a lot of the times they can go hand in hand when it comes down to actually deploying models into production.
Yeah, maybe some additional comment from my side. So I think James addressed several very important aspect of governance. In my opinion, governance starts also with knowing where are your models. So when we talk to enterprise clients, a lot of companies they don't know how many models they have. They don't know where are they. So there's no centralized catalog like Algorithmia can provide, right? So we have seen the demo before under the menu point algorithms. That's basically your centralized serving catalog. So you can basically provide a company-wide catalog for you to know from the governance perspective, how many models do I have, what are they, and who are the owners, how are they being called. if you want, you can also use organizations to manage basically the visibilities of each model. Let it be public available or only owned by a specific team, like the finance department, so nobody else have visibility to those models. So along that, there are a lot of additional features. For example, API calls. If you want to access the platform using API, you have to use the API key. So from there, you can define really fine granular access control to what the API key can do. Can it access the model? Can it access the data? If yes, read or write, and so on. So that gives you also a lot of availability. Besides that, the platform itself tracks about 90 operational metrics, from availability, utilization, billing, security, and so on. So that gives you a lot of insights into, how my platform has been used and who has called what and when. And, if something happens, you have basically the full transparency of what happened in your platform. And in addition to that, James mentioned, data drift, model drift, that's very important, very special for machine learning projects, right? So as Trey showed, before in the demo, with a single line of code, you are able to define your own a machine learning use case specific metrics that you want to track. For example, number of features, for example, approval rates or accuracy or precision recall. So everything that would make sense to you, you can use a single line of code to have the platform emit the metrics to a message broker. And from there, you can use whatever monitoring tool of your choice to analyze and monitor, alert in case something happens.
Awesome, that makes a lot of sense. So thank you. I did just throw this out into the chat. We have a few more minutes within our live Q&A. If you do have any questions after this session, don't hesitate to reach out to marketing@algorithmia.com, and we'd be happy to continue the conversation. One higher level conversation or question that I wanted to ask you all was more around the field of AI and ML. Especially over the past year or so, there's been a lot of new developments within this field. What trends have you seen, and what do you think will continue to be becoming more pertinent going into this next year?
I think James is probably more qualified to speak about that, right?
Yeah, fair. I can talk to some extent. So I've been working and building a lot of different types of machine learning workflows for quite a while at Algorithmia. I've got a little bit of gray beard. Been involved since the early days, and a lot of my early work was building out machine learning workflows and infrastructure. One of the really nice things that I really like to see is there has been some coalescence or kind of conformance from a machine learning framework perspective. So for instance, PyTorch and TensorFlow, they are two very, very powerful machine learning frameworks that can really accelerate developers' utility and expertise, and also allow them to kind of get to production faster. There's a lot of different power, a lot of power there, but in the past, they used to have very different APIs and very different ways of doing development, which made learning very, very challenging. More recently, those have definitely conformed and converged into kind of a more centralized format, which has definitely made it a lot easier to onboard, which is just fantastic across the board. Another thing too, from the natural language processing space, is you might be familiar with things like GPT-3 and so forth. Those have been massive recently, so that those have grown massively. The actual capabilities of natural language processing has grown leaps and bounds in recent, and even just within the year from where it was just last year. And a lot of that has a lot to do with the great work that the OpenAI team has been doing, along with, for example, the Hugging Face team in building out a reliable test bench and deployment platform called Transformers, which has been massive in that space.
That's exciting stuff. So we did have a great two-part question that came through the chat. So to build upon Trey's response, Can we deploy the platform on a cloud environment? And then does it support GPU fractionalization?
I know that we support all deployments. I'm not sure about GPU fractionalization.
I can answer the GPU part.
Yeah, please, James. I know the answer too, but you can go.
Oh, sure. Yeah. So yes, 100%. We actually have our own built-in GPU heterogeneous environment sharing system. We actually have a patent on it, funny enough, from way back in the day when we first built it out. We are actually also in direct conversation with NVIDIA on a regular basis to work with them to build up the next generation of virtualization-ready devices. So for example, with, I think it's the G5BNs, which are now on, or G5Bs, P5Bs actually, if I remember correctly, P5Bs, that's what it is, on AWS. Those, for instance, have that virtualization layers built in at the hardware level. We currently have systems at the software level, but we're actually looking to be able to conform to those standards as well. But rest assured, your code and how it's getting executed on the platform, if it needs to access the GPU, it will be able to share the GPU device, and your data and code is safe. We've built a lot about that, and if you want to read more about it, we can certainly get you some documentation.
There was also a talk from one of our leading engineers on Kubernetes event, I think in 2019. That's also publicly available on YouTube. And so this GPU, sharing feature gives you, a lot of possibility to saving costs, right? So I think everybody knows GPU is very expensive. And this is not trivial. So there is a discussion on Kubernetes on GitHub. I think that session has been open since 2017, September 2017. So it has been open for over 3 years now. And so that gives you a little bit idea, how challenging this problem is. But as James mentioned, we got it solved, and we have patent pending on that. Yeah.
That's great. Thank you so much. So I know that we're running up against time. So thank you again so much, Trey, James, and Zhilei, for working on this session. And thank you so much for everybody who joined us today. Again, if you do have any questions after this event, don't hesitate to reach out to us. Simply go to marketing at marketing@algorithmia.com, and we'd be happy to continue the conversation. So thanks so much, everybody.
Awesome.
And this wraps up our workshop. Firas, do you have any last thoughts or comments?
Oh, no, I think you closed it really well. So thank you everyone for joining. You'll be receiving an email for Hopin for the summit tomorrow. So we'll see everyone there.
Thanks, everybody.
Thank you. Bye.
Thank you, guys.